Okay. Don't take paper.
All right, take paper out so you can take notes. We're gonna get started with the lesson for today. I think everybody has it. Good, great. Okay, so we're gonna continue in sections 9.3 and 9.4 talking about parabolas. We first started out by talking about parabolas of the form y equals ax squared. Okay, so what are some things we can know about a parabola of this kind? Does anyone recall any features of a parabola that has that form?
Exponential.
It is exponential. Yes, that's true.
It can either be positive or negative.
Ah, yes. So how do we know if it's going to open up or open down?
If it's negative or positive.
Yeah, exactly. So if it's positive, it opens up. Yep. And if it's negative, the A here, if that's negative here, then it opens down. What if we're looking for what is a vertex first, and then if we are looking at one of this form, what is the vertex?
Like the point, like the top, like the crest or whatever, like the 0, 0 whatever.
Yes, 0, 0 is the answer for the vertex. Yeah, for this form. But yeah, so it's basically, well, sorry, this should be right here. But yeah, so the vertex is either the lowest point if it's positive and upward facing, or it's the highest point if it's downward facing. And when it's of this form, when your equation is of this form, the vertex is always 0, 0. Okay. Then we looked at kind of building on this. We looked at when we have some amount, which we call b equals ax squared. So if we have an equation here, instead of having y, we actually have some amount. Does anyone remember how we proceed to solve this type of equation? Yes, Grayson?
Divide by a first.
Yep. So yes, you start out, you take b over a equals, let's see. Yeah, so then that's going to be equals x squared, right? If we, yeah, so they'll cancel out over here. So if we have b over a equals x squared, what's the next step? Grayson?
Find the square root of b over a.
Exactly. So then x, sorry, I'm flipping order on you here, equals the square root. Well, I guess it would be,
Or positive.
yes, exactly, yeah. So plus minus the square root of b over a. Okay. So today, we're going to build on this and look at other parabolas that are a little more complex. So for today, let's see here. I'll leave my y equals here. So we're going to work on solving and graphing, primarily graphing initially, but then solving, when we have a parabola of this form. So it's ax squared, which is like what we had before, but it's going to be plus bx plus c.
Is this the quadratic? We'll get there.
We're getting there, yeah. So what are examples that have this form? Well, pretty much all projectiles, like we've talked about kind of related to this before. So what would be examples of things that are projectiles?
A ball.
Yeah, so like the path of a ball. Or we talked about related to your projects and stuff like a sprinkler.
What, somebody else? What are you guys doing? Let's hear about the project.
Yeah, hear about your
Yes.
projects. What do you?
I know what Ava's doing. What are you doing, Ava?
It didn't work out.
Oh, it
The
didn't
air
work
was-
out.
Well, my
Or did
dad,
the air move it?
well, it was because my dad had to be so far back and the air was too small.
Oh, I see.
No matter how
So your
much.
phone can pick it up.
Well, not very easily.
Okay.
I
So,
just did it.
anybody else do, what do they do?
I'm just doing them all.
You're doing
Your ball, okay.
What are you doing, Grayson?
I'm using my sink water because that's the thing.
Oh, okay, your sink water. That's a great idea. Never thought about sink water.
That is
That's a
interesting.
good one. Okay,
So,
what are you
Okay.
doing, Matt?
I think I should do a ball or no, a ball seems too plain. I'm gonna try something.
Okay, well, you guys were supposed to work on this past week.
Yeah.
uh-oh.
I'm thinking about it, but I haven't
No,
done it.
I wonder if I want to change it. That's what
Oh, okay.
What did you do this
a
week?
ball.
Okay, Brel, what do you do? A hose,
Oh,
okay.
okay.
Mason?
A ball as well.
Okay. Matthew?
No.
You haven't done it yet, okay. So you need to think of something, but all of the ones you're doing are those. What are other examples of parabolic paths that we could see?
A golf ball.
Yes,
Oh.
a golf ball.
we have our balls covered, I think.
A mortar.
Hey, that's not a bad, that's pretty
We
good.
did say it, but we're reviewing.
Yeah, we were reviewing from before.
What else?
A book. Throw a book.
Well,
Yeah, it would work.
yeah, it would work.
Basically
Doesn't have
anything
to.
that you can throw.
Throw up and it comes back down.
Yeah, exactly.
Hypothetically.
What about an airplane? Because it takes off and then it comes back down.
It has to be a glider then. It can't be an airplane.
Yeah, I was
That has
gonna
a
say-
power source though,
If
isn't
it
that?
has a power source, you can't really say it's gonna follow a parabola, cause it's more gonna go up and stabilize at a certain level
And then go straight.
and then go down.
So
Yeah.
the curve of the earth would technically keep the curve.
Haha, that's funny.
Yes, it probably
Satellite.
would, that's
A
true.
better example.
Do you wanna take a picture of that and measure?
Yeah, do that, take a picture of that and measure that for us.
Okay, so let's look at some examples here. This will be a review still probably, but so if we have a ball, like we were talking about here, and we throw it up in the air, this is kind of what its path looks like. We throw it straight up. There's our
It's coming back down.
it's coming back down. It goes up and comes back down. So when we graph that, normally we'll have time and then height. So it kind of looks like this, right? So when we start, it starts out at ground level or at the level you throw it from. And it goes up. And then as time goes, it goes back down to 0. Now an important thing here to think about is that this is not going to be exactly how your projects are going to work. So for your projects, I believe we're using height still for the y-axis, but for the x-axis, we're going to use, I believe, distance. So don't think you can use the equation with respect that is offered in the textbook related to time for your problem since it's using distance.
And I'm gonna ask again, am I allowed to use video games for this?
No, I said no.
How would you even use it?
It doesn't matter,
Armor
it doesn't
forging,
matter, I
shoot a
said
mortar,
no.
Or
I
grenade
said no,
launcher.
so I want you to see it in actual life.
Okay, then I'm gonna go buy a mortar or grenade launcher. Something like that.
Okay,
Minecraft isn't real. What? You should know that.
No, real life is based off of Minecraft. You know that, right?
So you can actually make another portal.
Alright, Matthew.
There is another one. I'll stick one.
I bet you could make a chicken.
Okay, so since we're working on this for the first section, this is 9.3 primarily. So 9.3. So we're trying to work on graphing this. I'm going to start with an equation that looks like this.
I think you didn't use it either.
Yeah, I think you're right. Okay,
That was
so
my good mark. Oh, did I give you this one? I keep
you gave me
stealing
the
it.
wrong one.
I don't know. Try that one.
Okay.
Yep.
There
that's
we
such
go.
a nice marker.
I thought that's the one I gave him. I'm sorry.
Okay. Is that readable or no?
Yeah, that's
That's
real.
Okay. Okay, so the first one I have as an example is 3x squared plus 4. Okay. Now, I want us to get used to this because this is going to relate to solving later on. So, what would be A in this formula?
3.
Yep, A equals 3. And what would be B?
No. Yeah,
There is a B.
there is a B.
No, there's B and C.
So, B actually would be 0.
Dang it. You didn't. I said there
Right? Because there is no B. So effectively it's x times 0. And just gets rid of that, right? So it's
Yeah, so it's
effectively
just not there.
yeah. But actually, well, yeah, you'd need to know that.
Wouldn't it be 1?
B?
Oh
No.
no, because there is no B.
Right.
Look at your equation.
Yeah. would be-
What number is multiplied by x?
A. AX.
No, the x term.
There is no x term. Yeah. So it's multiplied by 0 effectively, right?
Yeah.
You write it out. Okay. So we could look at it like this: y equals 3x squared plus 0x plus 4.
But we don't need to do that.
No.
You don't need this here, yeah, right. But that's effectively what it's doing, yeah.
Okay.
Does that make more sense?
Yeah.
Why would 4 equal? Okay. You need to
So then what would C equal?
4.
Yeah, C is 1.
You gotta take it and you go to it in front, and then you gotta put your go like this. Put your hair in front like this, and then go like that.
Matches.
It's okay, good one. I looked worse than you when I was in 8th grade.
So let's go ahead and
It was
do
so
this
bad.
with a table of values. So if we have
I'll show you
x
a picture.
and y,
Bigger glass.
Would a flare gun work?
let's see what I want to do here.
I have a flare gun.
Oh, I was. You're right. No, but it was like right as my hair started to come back.
They're gonna work.
Well, it would go like.
Oh, it's a table.
Okay, so,
Wait,
if we have this,
Is C equal to 4?
C is equal to
Okay.
4, correct. Yep. Yeah, so A is 3, B is 0, and C is 4. Yep.
C4.
Yeah. Okay, so for x, so for -3, what would we get for y? So if x is -3, what do we get for y?
31.
Correct. And notice that's positive, right? Because this is positive, our a is positive, and the x squared is always going to be positive. Okay, what's -2 for x?
16.
What did you say?
16.
16?
16, right?
Yeah.
16.
2 times 12. Yes, I believe that is correct. Okay, and then for -1? Yes?
7.
Yeah.
I
How about for 0?
4.
Yeah, that's pretty easy. And then what is 1?
7.
It's 7 as well, yeah. What can we gather from this table most likely?
That 1 is 7.
That's true. Yes.
Both negative and positive numbers are the same, like repeating kind of.
Okay,
Like
yeah.
negative
So this is a parabola, right? Because it's starting to repeat itself. So we're starting to get it's an upward facing parabola, right?
Yep.
And then, what else does it appear to be the case here?
It's
So with respect to the axes, do we know anything about that? Yes, Grayson.
Its vertex is 0, 4.
Yeah.
That's what I was gonna say, but I
Yep.
didn't know how to say it.
So this is 0, 4, and since it's upward facing, effectively, it never actually hits the x-axis, right? It's up above the x-axis. So that's what adding this 4 did for us. So that's so what's gonna happen is when we have equations of this y equals ax squared plus bx plus c, our vertex can be different from it's not always at the origin. It's not always at 0, 0. So that's something to keep in mind. Okay, so now we're going to talk about an application.
Ooh.
Yeah, it actually is usable. We can do something with this.
It's like a JAWS application.
Except we've already talked about this, so it's not really anything new, unfortunately. Let's see here. Okay, let's see here. So there's actually a formula that we can create for height, which relates to our projectiles that we've been talking about. So height in feet is equal to negative 16 t squared plus vt plus s. Okay, what does this all mean here? Okay, so this is height in feet. T is seconds after
Is that VT or is that just T? Do
This
T's
here?
look like pluses.
So this is a plus, this is VT,
Okay.
and this is a plus, and this is S.
Okay.
Yeah. Make your second T loop like your first one.
Yes, very good idea.
There you go.
Very good idea.
Okay.
Seconds after 1.
And then we have here initial velocity. And then here, I believe, is the initial height. Yep. So let's try an example. So let's imagine that a ball is launched from an initial height. So initial height So initial height of 8 feet, and it has an initial upward velocity of 48 feet a second. Okay. Initial.
You say 38?
Yeah, 48.
Initial money.
Velocity
Oh, initial velocity.
of 48 feet a second. So let's try to write the equation. So what would the equation look like? So we have height equals what?
Negative 16t.
Okay.
Square.
Thank you. Thank you guys. I get it upset.
Yeah.
plus 48.
Yeah, plus 48 T.
Yep.
48 T net.
Oh, sorry. Grayson, you got it.
Plus 8.
Really?
Plus 8. Yep, that's it.
We're all
Very
so
good.
smart, guys.
I thought it was still S.
So S equals 8.
No, I got the weirdest.
No, I got a
Oh,
weirder
it's like
one.
crooked. Oh, both of them are crooked.
And then you saw.
Mine's more crooked.
Oh! The heck?
I think.
Why do they do that? I mean,
It's a genetic thing.
I thought my fingers were weird.
I think I'm pretty normal.
I mean,
know.
Okay.
Okay, so what would be our value after 2 seconds? This should be pretty quick, right? So just up here.
Cool.
mine's cooler. 40. No,
Very good.
holy moly.
Yeah.
This is some riveting stuff right here.
Isn't it?
Yeah.
No, it's helpful if you're actually solving some of these problems. But okay, so what would be the maximum height? So if you can use Desmos or if you have that available.
Or how else could they find it?
Well, it's not more than 9 seconds. So.
By graphing it.
Or you can make a table, right?
Yep.
And find out where does it start coming back down.
Mm-hmm.
So put numbers in, make your table. So let's do that right now. You know 2 seconds, it's 90 feet. So I would try 2, 3, and 1 just to see what,
3 seconds is the highest.
how do you know?
Let's put that in.
Well, what's 4?
It's
So try it.
184.
Plus 5.
Yeah.
40.
What?
Oh,
So 4 is the highest.
No, yes.
No.
No.
it's not.
No, it's 3.
what is 3?
3 is 296.
Oh yeah, so 3 is the highest.
Well, let's
2
talk
No,
about
wait, no,
this.
3 is. Wait.
Okay, so
Then
I want you right now to
How about
go
your
from 2 to 6 in a chart. So make your X's be, or your T's from 2 to 6.
I did everything wrong. Don't listen to me.
No, I got
3,
8 for
4,
3.
I know. I did it all wrong.
6.
I lost my calculator.
You can use mine.
Okay,
I-
find the heights for each of
Let me
those.
just use my brain.
That should give us a little bit of an idea. See where it's happening.
No, I'm just, my eyes are glazed over right now, I'm not looking. 40. 4
It's the
1.
same as that.
I'm just 40 for 1. I'm just like,
No.
I think you can go back to my brain. I think
1
that's
equals 40?
I don't think so.
I think it is.
2
Yes,
equals
it-
40.
Are you saying my brain is
No,
really?
1 is not
Yes.
equal to
Gosh,
40.
dang it, Grayson.
56 minus, oh, it is. So that means, okay,
Grayson, what did you do? You went 6.
Put-
Why did you go
make
6,
your thing 1 too.
This is for like
Put
elevated.
a thing in for 1, in front of that. Okay, I'm just gonna tell you, don't do 4, 5, and 6, guys.
Just do 3.
I
The
wanna-
highest
Do
is
1, 2, and 3.
The highest is only 2 seconds. At 40.
Okay, what is number 1? 1 second is how far?
40, 1, what? And then it goes back to 8. So
1 is 42.
I think we're gonna need Desmos to get these.
No, we
answers.
aren't.
Oh, we aren't? We're
I
gonna
can
get it?
show you.
Oh, okay.
What if we use?
What did you get for 1?
40.
Yeah.
Height is
Yeah.
40.
Okay.
What did
That
you
was
get
2.
for 2?
2 is
40.
40, right?
2 is
Both
40.
of them are 40.
Oh, both of them are 40.
Okay, I get it now.
Okay.
I understand it now.
Now what does that mean? Does that mean 1 and 2 seconds are both the highest point?
That means it flattens.
No.
Because
They're like 2,
Yeah, so where's the middle point going to be?
1.5.
1.5 seconds.
Wait, so does that mean it goes higher in that? point?
Yes,
It does,
at
yeah.
1.5 seconds.
No.
So-
Okay.
Show it on a graph to show it's at 40.
That's crazy, bro. I'm like shell shocked. My entire world is wrong.
So we got
44.
this is T, right?
Yeah,
Height. And we've got, so we'll do it in increments of 10 or
Sure.
10, 20, 30, 40. 1, 2, 3, 4. Okay, so 140.
Okay, so if you have 2 points that are at equal distance from each other, is it starting to form the parabola already?
Yes. No.
Yes, because,
Yes,
yeah,
I mean, yes.
anytime.
That's
So
what I
where
said
is the highest point going to be?
1.5.
Yeah, it's gonna be right in the middle of those two. So the highest point is 1.5, so now you calculate 1.5.
It's 44.
Okay. So
That's the right answer,
1.5
yeah.
is
That is the
44.
right answer, yep. Okay.
Okay.
You're so sweaty.
So if you get two that are identical, if you get 2 points that are identical on your graph,
Then you know that they're somewhere higher.
it's right in the middle of those two identical points. Exact middle of those is where your highest point will be, or your lowest point, depending on what type of curve it is. Okay, it has to be exactly in the middle of those two.
Interesting.
So that's how that works.
Okay, now we're gonna switch from feet to meters. There's a little bit of a different equation, obviously, for that. So,
Wait. At 1.55 seconds, it's 45.4.
Oh.
No, it couldn't be. I'd have to see it. It has to be directly in the middle.
Then why is that right?
I don't know, I'd have to see how you put it in your calculator.
okay, so I think there should be a formula in your book, right, for meters? Let's see, 9.4. I have the,
I didn't realize we did additional swimming.
yeah, we're going for metric here.
No,
I love the
that was
metric
fine.
system.
43.96.
I use meters a lot.
Yeah, because you're a track star.
Yeah, for some reason they use meters, but only in running events. In like javelin and
They use
chocolate,
feet?
They use feet. Yeah,
Dang.
I don't get it. It makes no sense. But I guess who's gonna say, oh yeah, I run like the 5,600 feet, right? Isn't that how many
Yeah.
feet I am? Mile, yeah. It sounds nicer to just say I run the 1,600 feet. 5,200. I run 5,000.
I
Okay,
thought it was like 25.
Back on topic here.
Yeah.
So, yes, your height in meters is equal to negative 4.9 t squared, still seconds, plus your initial velocity times t, plus your initial height. So say we threw something from an initial height, like off a cliff, say it was 100 meters, what would the formula be? So h equals what?
You threw it off. How high?
So say we have a cliff, and we throw a ball or whatever.
Can we put in negative numbers in for t?
Uh,
Actually, wait, no, that's time.
that's time. Yeah, that's time. Yeah. So we're throwing, and it's an initial height. This cliff is 100 meters.
The
Okay.
s would change.
Correct. What would we have for VT?
Well, if you're just dropping a ball, you're just making like a half of it.
Yes, you are.
So the VT is just 0. Yeah, exactly. So what you
dropping it, it'll go down. Well,
so you have
yes,
negative
you can,
4.9 t plus 0. Well, I'll make that bigger. 0 t.
Why are we not
We can
putting? Why are we not putting in negative 16 in anymore?
Because we're doing in meters. This is the height in meters.
So there's two different ways to measure it.
Oh,
Feet
they don't.
per second or meters per second.
I wouldn't.
And I'll tell you, you've got it too.
I don't think. Yeah, no. It's meters.
Negative 4.9 t. No. Oh yeah, that's true.
Centimeters would make sense.
But t squared.
100.
Kind of like
Minor detail.
my ident or
Right.
whatever I wrote.
Yes. Okay. All right. So our formula. That's the first stage is to get our formula. So that's negative 4.9 t squared plus 100. And then we want to actually try to solve this for when it hits the ground. So when does our ball hit 0? How would we set this up for that problem?
We made a table.
Well, I don't think we have to make a table for this one. But so what do we know? We know if we're looking for a height of 0, right? Grayson?
Yeah, you just replace 0 with or his height with 0.
Yep.
Solve it.
Yeah, it's that simple. You just go 0 equals negative 4.9 t squared plus 100. Okay, so what would be the next step?
Minus 100 on both sides.
So we got negative 100 equals negative 4.9 t squared. What's next?
Divide those.
Yep, divide both sides by 4.9. What does that give you?
Not a very good number.
You're right about that, yeah. Okay, divided by 4.9.
Negative 95.1.
Okay, what can we tell right away? Should this be positive or negative?
Positive.
It should be positive because it's a negative and a negative, right? So we know it's positive.
Wait, no, I did that wrong.
Yes, you did.
It's 20.409.
Yes, so so t squared, so t squared equals 20, I'm gonna call it 0.41.
Square root it.
Oh yeah.
Nice job, nice.
So yeah, so square root of 20.41 equals, well, is this plus minus?
No.
It's not plus minus,
It's
yeah,
just
because
plus.
this is time. We don't have imaginary time unless we're Stephen Hawking. Okay, so yeah, so that's gonna equal, what does that equal?
That's you, Grayson.
About 4.51.
Yeah, 4.52 is what I have, but that sounds like you're on track.
Come on, Grayson.
5.75.
Okay, so
Yeah, 5.2.
what would be the maximum height for this kind of an equation? Anyone guess that?
Do we need to make another graph?
Grayson.
100.
Right, that's where we started.
yeah.
Yeah, so if we're dropping it straight off a cliff, then our initial height is, yeah, it's gonna be 100 meters, yeah. So that's, you can also see because if you plug in, well, the easiest way to figure this out is the lowest point, 0, and the highest point, since it's decreasing, is gonna be the 100, yeah. Okay. Still got a little time before break. Okay. So, it's problem on board time. Okay, so you can,
But there's a problem on deck. There's no problem on board.
problem on board, yeah, on whiteboard. Okay, let's see.
Sorry, I just had to.
That's just a face value. That was not a voice slapper.
So now you're laughing.
Trying not to cringe so hard.